Geothermal energy is energy in the form of heat that is stored within the Earth. The Earth's core is an unlimited source of heat. It is the source of volcanoes, hot springs, and geysers. Using modern technology, this resource can be tapped into for the purpose of generating electricity. Geothermal power plants basically consist of production wells, pumps, turbines, generators, and reinjection wells. The production wells are drilled deep beneath the Earth's crust to extract hot water. This heat can then be used to run a turbine connected to a generator which produces electricity.
What are the types of geothermal electrical energy plants?
There are four main types of geothermal power plant that produce electricity. They are the dry steam, the single flash steam, the double flash steam, and the binary cycle. Currently, the binary cycle and the double flash steam are the most widely used. The most efficient type is the dry steam power plant, but most of the world's usable sites have already been exploited. In the dry steam power plant, steam enters from the production well and expands through a turbine. The blades of the turbine are caused to rotate, which then powers a generator and produces electricity, which is sent to the grid. Steam is then re-injected as liquid into the injection well. In the single flash steam and the double flash steam power plant, geothermal fluid enters from the production well, is flashed to steam in an external tank, and is then piped into the turbine. In the binary cycle power plant, geothermal fluid is piped through a heat exchanger, where the heat is then carried to the turbine through working fluid.
Calpine Corporation made a significant contribution to this geothermal project by allowing both high school and post-secondary students to tour their facility in order to provide insight into geothermal power extraction. The Geysers is located in Middletown, California, about 100 miles north of San Francisco.
How does the dry steam power plants, like the one at the Geysers, work, and what are its parts?
This model, provided by Calpine, shows the use of a dry steam power plant to tap into the earth via a production well and through a reinjection well. The production wells at Calpine average about 8,500 feet, making their way through the upper cap rock, permeable reservoir, and into the lower hot rock. These production wells are then used to draw dry steam directly into a turbine, coupled with a generator, to produce electricity. The electricity makes its way through a transformer so that an appropriate voltage is maintained before it is delivered to the grid, making it accessible. Once the superheated steam's energy has been spent into the turbine, the saturated steam passes through a condenser and becomes a liquid which can then be pumped into a cooling tower and then back into the earth through a reinjection well. Although reinjection may not make the energy source renewable, at least not on the scale of a human lifetime, it helps the earth maintain stability and keeps the superheated steam's temperature from falling as rapidly as would be the case without reinjection.
The problem with the geothermal process is it's not a very sustainable system. In order for something to exist for a long period of time, you have to put in just as much as you take out. It's one of the main reasons why we're running out of fossil fuels today. Let me show you an example. If I put in just as much water as I'm taking out, it's going to last forever. Now let me show you what happens when a system is not sustainable. You pretty much just run out.
What is the current potential and challenges for the energy production?
Currently, geothermal exploration is only taking advantage of a small amount of the heat energy stored in the Earth's crust, even though 99% of the volume of our planet deals with temperatures of more than 1,000 degrees Celsius. Besides that, from the very little amount of energy that we get to extract from deep layers of the Earth, only about 15% of it is converted into electricity, and the other 85% is basically wasted energy. Therefore, finding ways to be more efficient in the use of geothermal energy without altering the natural equilibrium of our planet is one of the biggest challenges for geothermal energy production and for the actual and future generations of geologists and engineers.